In the 1950s and 60s, physicists discovered many elementary particles. And there were so many of them that kind of physicists were starting to lose track what they were. The great physicist Wolfgang Pauli even joked that quantum physics was turning into botany. It was almost like you had all these species which nobody knew where they came from, or as another physicist quipped, who ordered them. Physicists desperately needed to rein in those particles to find some kind of organizational rules, an organizational scheme for what they were and what was the meaning of all of them. And so there was a search for such an organizational scheme. And Murray Gell-Man was one of the people who helped devise such a scheme. And his idea was to group those particles into families of 8 and 10 particles. And he noticed that within those groups, those particles had very similar properties, and there was sort of a nice framework, a nice pattern forming. But then the question was why? Why 8 and 10 and not 7 or 11? And then Gell-Man understood that 8 and 10 were numbers characteristic of a certain group called SU3, special unitary group. And so then he postulated that perhaps that group was responsible for the symmetries of those elementary particles. But, and that idea led him to something which sounded totally crazy at the time, that actually there were 3 smaller particles which he named quarks, such that all of these known particles would be the composites of those quarks, would be built from those quarks, kind of like in a Lego game, where you would have these fundamental objects from which you will create sort of different shapes. That's what it looked like. So some particles, like a proton and neutron, would have 3 quarks, and some particles would have 2. And so that was the way that this abstract mathematical theory of symmetries found its way to describe to answer some of the fundamental questions of quantum physics.